OK, the third type of attack or detection strategy is anomaly-based detection. And here, we're going to take the idea we just used, where we kept a list of what's allowed and then tried to detect things outside of what's allowed. But instead of manually specifying, because that's tedious, let's try to specify things automatically. So somehow, maybe using some machine learning model, we'll develop a model automatically of what normal activity looks like. And that model has to learn what it means to be normal. And then if at any time our model thinks that something doesn't look normal, it will alert. So here we're taking advantage of the fact that in many cases, attacks look different from normal user input. So instead of manually specifying attacks and normal user input, could we have some sort of machine learning model figure that out and automatically detect what's normal and what's not? That's the idea behind anomaly-based detection. So for example, maybe you have a bunch of logs of inputs that the user has provided. You can train the model on those logs so that it now has some idea of what's normal and what's not. So that's the idea. Keep a model alert on things that the model says are unusual. So here are some examples. Now, we're not a machine learning class, so I can't tell you exactly how those models would work. That's an active area that people are researching. But here are some examples, and they're a little bit contrived, so bear with me. But in our path traversal attack, if we feed in lots of training input into our model, so we give the model a lot of examples that it can use to learn about what's normal, maybe our model is pretty smart, and it learns that ... seems to be very correlated with attacks. In other words, ... seems to correspond to cases where there's attacks, and inputs without ... seem to frequently correspond to cases with no attacks. That's something that the model might be able to automatically learn. Then the model would start alerting if it sees ... because the model sees that and thinks that it's very unusual. So that's something the model could do. Now, machine learning models can be a good deal more complicated, but that's a simpler example. Or we could consider buffer overflows. So maybe we give the model a lot of inputs to the C program, and we let the model learn that some of these are attacks and some of these are not attacks. And we want the model to figure out and be able to predict that in the future. So we give the model lots of examples. We say, here's a sample attack, here's another sample attack, here's a sample non-attack, here's a sample non-attack. And we let the model train on those inputs. And maybe the model learns something like users seem to always type the letters on the keyboard. That could be something that our model learns. It learns that the characters that you can type on your keyboard, like letters and the period and the dash, those seem to be highly correlated with legitimate user inputs. However, characters that can't be typed on a keyboard seem to correlate with attacks. Like when someone tries to input a raw byte, \x30 or something, well, that's not a character that you can type on the keyboard. It's a raw byte. If the model is somehow able to learn that, it can alert if the input contains keys that don't show up on the keyboard. And remember, the idea here is that the user doesn't have to manually specify any of this stuff. The user can. Then you would be doing specification-based detection. But if you want a model to learn these patterns, then that's something you can try and have the model do, and you'd be running anomaly-based detection. Here are some trade-offs. This can detect attacks you haven't seen before for similar reasons to specification-based detection. If an attack is brand new, it might look unusual and get detected. But here are some drawbacks. Models aren't perfect. So you might know from using ChatGPT or something that machine learning can give you wrong answers sometimes. The models aren't always 100% accurate. And so that means that there could be an attack that you knew about, but the model messed up and said it wasn't an attack. That's something you have to worry about. If a new attack appears, but it doesn't look unusual, somehow your model thinks that it looks OK, then that attack could be allowed and it doesn't get flagged. There are some problems where you feed in bad data into your model. So if you confuse your model by giving it some inputs that are mislabeled or somehow incorrect, you could confuse your model and cause it to make incorrect decisions. depending on what you mean by unusual, you could get high false positive rates. So if you try to make a very narrow definition of what's normal, then most things will look unusual, and that could create a lot of false positives. Or if you try to widen your scope and say almost everything is normal, just show me the most unusual inputs, then you might start to have false negatives where you miss slightly unusual attacks. So because of these drawbacks and the fact that these models aren't always perfect, people don't tend to use anomaly-based detection in practice, but it's a great subject if you're trying to write research papers and develop these models.